Beans, lentils, chickpeas, broad beans, and other legumes have been fundamental pillars of the human diet since we abandoned the nomadic way of life. However, in the frenzy of modernity and food industrialization, these nutritional treasures were gradually relegated to the category of poor man's food or secondary foods. A monumental mistake that has deprived entire generations of one of the most complete, sustainable, and economical sources of protein in existence. The history of legumes is, in many ways, the history of civilization. Archaeologists have found evidence of their cultivation dating back more than 10,000 years. Cultures as diverse as the Egyptian, Roman, Chinese, and pre-Columbian developed sophisticated techniques for their cultivation, storage, and preparation. It is no coincidence that great civilizations flourished alongside the dominance of legumes. These foods not only provided a stable source of nutrients, but also enriched the soils where they were grown, thanks to their unique ability to fix atmospheric nitrogen nutritionally. Legumes represent a marvel of nature. A single handful of these tiny treasures contains an amino acid profile that, when properly supplemented, can rival any animal source of protein. Black beans, for example, contain approximately 22 grams of protein per 100 grams in their dry form, while lentils reach 26 grams, numbers that are astonishingly close to those of beef, which offers about 28 grams per 100 grams. But the real secret of legumes lies not only in the quantity of protein they provide, but in their quality and composition. Legumes are particularly rich in lysine, an essential amino acid usually present in limited quantities in cereals. This natural complementarity explains why traditional cultures around the world intuitively developed combinations such as rice with beans, wheat with chickpeas, or corn with beans. These combinations are not accidental. They are the result of nutritional wisdom passed down through generations, which modern science has validated by confirming that these blends create complete protein profiles, with all the essential amino acids our bodies need. Beyond their impressive protein content, legumes are true powerhouses of essential micronutrients for muscle health. Iron, a critical mineral for oxygen transport in the blood, and therefore for optimal muscle function, is found in significant quantities in lentils and beans. A single plate of lentils can provide up to 6 milligrams of iron, approximately 1/3 of an adult's daily requirement. This mineral not only prevents anemia, but is essential for the synthesis of myoglobin, the protein that stores oxygen in muscles. Magnesium, another mineral abundant in legumes, plays a crucial role in more than 300 enzymatic reactions in our bodies, many of which are directly related to muscle energy production and protein synthesis. Magnesium deficiency frequently manifests as cramps, muscle weakness, and fatigue, symptoms that many athletes experience without relating them to nutritional deficiencies. 1 cup of black beans provides approximately 120 milligrams of magnesium, about 1/3 of the recommended daily intake. Zinc, present in significant amounts in chickpeas and lentils, is another essential mineral for muscle health. This trace element is actively involved in protein synthesis, the production of testosterone, a key hormone for muscle development, and tissue repair processes. Recent studies suggest that zinc deficiency can significantly compromise recovery after intense exercise. Another revolutionary aspect of legumes is their extraordinary fiber content, both soluble and insoluble. Far from being a filler component, fiber plays a fundamental role in optimizing protein absorption. Soluble fiber, abundant in legumes like chickpeas, slows digestion, allowing a gradual release of amino acids into the bloodstream. This process prevents insulin spikes and promotes more efficient protein utilization by muscle tissue. Additionally, fiber nourishes our gut microbiota, whose influence on overall health and muscle metabolism we are only just beginning to fully understand. The complex carbohydrates found in legumes also deserve special mention. Unlike simple sugars, which cause sudden increases in blood glucose, the carbohydrates in legumes are digested slowly, providing a stable source of energy. This characteristic makes them ideal allies for endurance athletes who need to maintain constant energy levels for extended periods. A study published in the Journal of Sports Science and Medicine showed that runners who consumed a diet rich in legumes showed better endurance performance and less muscle fatigue than those who based their diet on refined carbohydrate sources. From a practical perspective, few protein sources can compete with legumes in terms of affordability. In a global context where quality animal protein is prohibitively expensive for large segments of the population, legumes offer a nutritious, sustainable, and affordable alternative. A kilogram of lentils, which can provide enough protein for numerous meals, costs a fraction of what an equivalent amount of animal protein would cost. This affordability, however, does not imply a nutritional compromise. On the contrary, it represents an opportunity to democratize access to quality nutrition. Environmental sustainability is another factor that positions legumes as a key player in the food of the future. Growing legumes requires significantly less water than meat production, generates a much smaller carbon footprint and, as mentioned above, contributes to soil fertility rather than depleting it. On a planet with finite resources and a growing population, legumes offer a solution that aligns our nutritional needs with ecological responsibility. The culinary versatility of legumes is also remarkable. From chickpea hummus to lentil salads, from bean chili to veggie burgers, the possibilities are virtually endless. This adaptability allows them to be incorporated into any type of diet, from Mediterranean to Asian, from vegetarian to omnivorous. Each culture has developed specific techniques to maximize the digestibility and flavor of legumes. Prolonged soaking in Mediterranean cultures, fermentation in Asian traditions, sprouting in Ayurvedic practices. These techniques not only enhance the organoleptic qualities of legumes, but also increase the bioavailability of their nutrients and reduce anti-nutritional factors such as phytates and lectins. Contrary to popular belief, legumes can be extraordinarily digestive when prepared properly. Pre-soaking, simmering, and adding carminative spices such as cumin, fennel, or coriander can minimize or eliminate the unwanted gastrointestinal effects some people experience. Furthermore, regular consumption promotes adaptations in our gut microbiota that progressively improve our ability to digest these foods. It's important to emphasize that legumes are not merely an alternative to animal protein for those who cannot or do not want to consume it. They are in their own right superfoods that should occupy a privileged place in any diet aimed at optimizing muscle health. Even for high-performance athletes, the strategic incorporation of legumes provides benefits that go beyond their protein content, such as improved recovery thanks to their antioxidant compounds, optimized intestinal transit, and stabilizing energy levels. Scientific evidence supporting the value of legumes for muscle health continues to accumulate. A study published in the American Journal of Clinical Nutrition found that subjects who regularly consumed legumes maintained their muscle mass better during periods of aging compared to those who consumed equivalent amounts of protein from other sources. Another study in the Journal of the International Society of Sports Nutrition showed that vegetarian athletes with a high intake of legumes had more favorable inflammatory profiles after intense exercise, suggesting a potential role for these foods in accelerating muscle recovery. While it's true that legumes considered individually have some limitations in their amino acid profile, they are generally low in methionine and cysteine. These limitations are easily overcome through intelligent food combinations. The traditional combination of legumes with grains not only creates a complete protein profile, but also offers a synergistic nutritional matrix where vitamins, minerals, and phytonutrients work in concert to enhance each other's effects. It's time to rediscover these forgotten giants of nutrition, to reintroduce them not as a subsistence food or a cheap alternative, but as protagonists of a conscious diet aimed at maximizing our muscular and overall health. Legumes are not just another source of protein. They are probably one of the most complete, sustainable, and beneficial sources that nature has offered us. To kickstart this reintegration, consider these practical strategies. Replace half the meat in your usual recipes with legumes. Experiment with homemade bean burgers. Incorporate hummus as a post-workout snack. Add lentils to your salads. Try tempeh, a fermented soy product, as a protein alternative in your meals. Each of these small additions represents a significant step toward more complete nutrition and optimized muscle health. Legumes have nourished and strengthened humanity for millennia. In the age of artificial protein supplements and high-protein diets based on animal products, these humble foods remind us that true nutrition doesn't need to be complicated or expensive. Sometimes the most powerful solutions are also the simplest, most accessible, and most sustainable. It's time for legumes to reclaim their starring place on our tables and in our strategy for building and maintaining strong, healthy muscles. There is one food in nature so perfectly designed that it contains within itself all the nutrients necessary to create life. A food that, despite its apparent simplicity, is a biochemical masterpiece whose nutritional composition has fascinated scientists for generations. This ubiquitous yet frequently misunderstood food is the egg. The history of the egg as a human food is lost in the mists of time. Ever since our ancestors discovered they could collect the eggs of wild birds, they became a coveted nutritional treasure. With the domestication of chickens, approximately 8,000 years ago in Southeast Asia, the egg became one of the first functional foods cultivated specifically for its nutritional properties. Cultures as diverse as the Egyptian, Roman, Chinese, and pre-Columbian incorporated the egg not only into their diets, but also into their traditional medicine and rituals, intuitively recognizing its exceptional value. However, in the final decades of the 20th century, eggs suffered a smear campaign that still resonates in the collective mind today. Concerns about their cholesterol content led to recommendations drastically limiting their consumption, especially for people with cardiovascular risk factors. These recommendations, although well-intentioned, were based on an incomplete understanding of cholesterol metabolism and on studies that have subsequently been revealed to be methodologically deficient. Modern nutritional science has rehabilitated the egg, demonstrating that concerns about its impact on blood cholesterol levels were largely unfounded. Recent studies have confirmed that for most people, regular egg consumption does not significantly increase cardiovascular risk. In fact, eggs contain nutrients such as choline, lutein, and zeaxanthin that may have protective effects on the cardiovascular and neurological systems. From a protein perspective, eggs are probably the most complete and bioavailable source found in nature. A large egg contains approximately 6 grams of protein, distributed between the white and the yolk. This amount may seem modest compared to other sources, but what's extraordinary about eggs isn't the quantity but the quality of their protein. Egg protein has a nearly perfect amino acid profile for human needs, with all essential amino acids present in optimal proportions. This balance is reflected in its PDCAAS, protein digestibility corrected amino acid score, an indicator of protein quality that considers both amino acid profile and digestibility. On this scale, where the maximum is 1, egg protein obtains a perfect score, even surpassing high-quality sources such as meat or dairy. Particularly noteworthy is the leucine content in eggs. This essential amino acid plays a crucial role in activating the mTOR, mammalian target of rapamycin pathway, a fundamental molecular mechanism for muscle protein synthesis. Recent studies suggest that leucine not only contributes as a building material for muscles, but also acts as a biochemical signal that initiates and regulates the synthesis process. A single large egg contains approximately 500 milligrams of leucine, a significant amount considering that the threshold for maximum activation of muscle protein synthesis is estimated to be about 2 to 3 grams of leucine per meal. The bioavailability of egg protein is another distinguishing factor. While many plant proteins have anti-nutritional factors that limit their absorption, egg protein is digested and assimilated with extraordinary efficiency. Isotopic labeling studies have shown that the percentage of egg protein actually incorporated into muscle tissue is significantly higher than that of most sources, including commercial protein supplements. But the nutritional value of eggs goes far beyond their protein content. The yolk, unfairly demonized for years, is actually a nutritional matrix of extraordinary richness. Choline, an essential nutrient present in significant quantities in the yolk, plays a fundamental role in neuromuscular function and in the synthesis of phosphatidylcholine, a crucial component of cell membranes, including those of muscle cells. Choline deficiency has been associated with muscle and liver dysfunction, and it is estimated that a high percentage of the population does not meet the recommended intake levels for this nutrient. A single egg provides approximately 150 milligrams of choline, a substantial amount considering that the recommended daily intake is 500 to 550 milligrams B vitamins. Especially B12, riboflavin, and pantothenic acid are abundant in eggs. These vitamins are essential cofactors in energy and protein metabolism. Vitamin B12 in particular is critical for neurological function and the formation of red blood cells, which carry oxygen to muscles. For people who limit or eliminate animal products from their diet, getting enough B12 can be a challenge, making eggs a valuable source if included in flexible vegetarian diets. Vitamin D, another nutrient frequently deficient in the general population, is present in appreciable amounts in eggs, especially those from hens-fed enriched diets. This vitamin, which actually functions as a hormone, regulates the absorption of calcium and phosphorus, minerals essential for bone health and muscle function. Vitamin D deficiency has been associated with muscle weakness, chronic pain, and poor recovery from exercise. A study published in the Journal of Clinical Endocrinology and Metabolism found that vitamin D supplementation in deficient individuals significantly improved muscle strength and function, suggesting a direct role for this nutrient in muscle. Physiology. The minerals present in eggs, although not in such impressive quantities as in other foods, are present in highly bioavailable forms. Selenium, a trace mineral with potent antioxidant properties, is particularly abundant. This mineral is part of selenoproteins, enzymes that protect muscle cells from the oxidative stress generated during intense exercise. Heme iron, present in the yolk, is absorbed more efficiently than non-heme iron from plant sources, helping to prevent iron deficiency anemia, a condition that severely compromises physical performance. The carotenoids lutein and zeaxanthin, responsible for the yolk's yellow-orange color, are powerful antioxidants that play an important role in eye health. Although their relationship with muscle function is less direct, the protection they provide against oxidative stress benefits the entire body, including muscle tissue. Recent studies suggest that these carotenoids may also accumulate in the brain, protecting against age-related cognitive decline. The distribution of fats in eggs deserves special mention. Contrary to popular perception, not all egg fats are saturated. In fact, approximately 60% of the fats in the yolk are unsaturated, including monounsaturated fats similar to those in olive oil and polyunsaturated fats such as omega-3s. The exact proportion varies depending on the hen's diet, with eggs from hens-fed omega-3 enriched diets being a significant source of these essential fatty acids. Omega-3s, especially long-chain omega-3s like EPA and DHA, play a crucial role in reducing post-exercise muscle inflammation and optimizing insulin sensitivity, a key factor in protein utilization for muscle synthesis. From a practical perspective, few foods match the egg in terms of culinary versatility and convenience. It can be prepared in countless ways, from the simplest, such as hard-boiled or scrambled, to sophisticated preparations. Its relatively neutral flavor allows it to be incorporated into both savory and sweet dishes. For athletes and active people, hard-boiled eggs represent a perfect protein snack. Portable, they don't require immediate refrigeration, they provide high-quality protein and essential micronutrients, and they come in their own biodegradable packaging. The nutritional cost-benefit ratio of eggs is exceptional. Even considering premium options such as organic eggs or those from hens-fed omega-3s, the cost per gram of complete protein is still lower than that of many quality meats or protein supplements. This affordability makes eggs a democratic choice for improving the protein quality of a diet, regardless of socioeconomic status. It's important to address the issue of cholesterol, which has long clouded the egg's reputation. Current research has shown that, for the vast majority of people, dietary cholesterol has a minimal impact on blood cholesterol levels. Our liver adjusts its own cholesterol production in response to dietary intake, maintaining a homeostatic balance. Large-scale studies, such as one published in JAMA, Journal of the American Medical Association, in 1999, which followed more than 117,000 people for 8 to 14 years, found no significant association between egg consumption and the risk of cardiovascular disease in healthy individuals. Even for populations traditionally considered sensitive to dietary cholesterol, such as those with type 2 diabetes, the current evidence is more nuanced. While some studies suggest caution, others have found no adverse effects from moderate egg consumption. In any case, the response appears to be highly individualized, underscoring the importance of personalized recommendations based on each person's specific metabolic profile.